So the best way perhaps to see this in action is to use our own security manager, and we'll see why this makes life slightly easier in a moment. So here I've defined a class called mySecurityManager that extends Security Manager, and that has a method called listPermissions, just something we can call to list out all the permissions at a given point in time. To use the Security Manager, we have to add it into the application and tell the application we want to use our Security Manager. And we've seen previously we do that by calling system.setSecurityManager. I just passed this new mySecurityManager. There's a mirror call to this called getSecurityManager. So just to see this in action, I can say mySecurityManager, SecurityManager equals system.getSecurityManager. And this thing I need to cast to be a mySecurityManager. And then once we have that, I can call SecurityManager.listPermissions. So it's listPermissions where we'll do all the work. So in here, the first thing I want to do is to get hold of the default policy class. So I can say policy equals get policy. And this returns me the policy singleton. So I can say policy get policy and get back the policy singleton. Now the reason I want to create my own security manager is that the security manager has a helper class called getClassContext. GetClassContext returns a list of classes that are currently involved in security for this application. I'm being slightly hazy here. We'll explain exactly what that means in a few moments' time. So what getClassContext returns is an array of classes. So I can say class array classes equals getClassContext. Once I have that, I can iterate over all of these classes. So I can say for class in classes. Then inside here, I can get the protection domain for each class in this iteration. So class.getProtectionDomain. And then from the protection domain, I can get the code source for, again, each class. So I can say CodeSource CS equals pd.getCodeSource. So once I have the code source, I can use the policy to get permissions. So I can say policy.getPermissions, and I can pass it the code source. And what this returns is a permissions collection. So I can say permissions collection equals policy.getPermissions. So once I have the permissions collection, I want to enumerate them. The permissions collection has an elements method, which returns me an enumeration of permission objects. And once I have that, I can iterate over these. So permissions.hasMoreElements, and then just simply print out permissions.nextElement. And that will call toString on the permission and print out the permission. Now one last thing to point out, I'm going to run this with a security manager. Indeed, we set that security manager here. So I need to make sure the permissions for this application are correct. So I have a policy file here. In this policy file, we grant ourselves two further permissions. We need the permission to allow us to read the policy. We need the permission to allow us to read the protection domains. And if we don't grant ourselves these, then the code will simply fail to run. So if I jump to the command prompt here, and from here, run Java, pointing at that policy file, and then com_pluralsight main is just the main class of the application. And if I run this, we'll print out all of our permissions. And we notice essentially what we get here are the permissions from the policy file. So we get various property permissions, we can read the specification, we get the extra permissions we've added like getProtectionDomain and getPolicy. So this is how our code internally, if we need to, can read and check these permissions directly. Now, as we'll see later, this is not actually how permission checks are done. What we can see here, this gives us one way to access all the given permissions if we ever need to do that. Now that we've seen how to get these permissions, we need to take a look at one extra thing for the check, and that is something called the code stack walk, and we'll see that in the next module.